You are standing at your kitchen counter, still a bit bleary-eyed, performing one of the most ordinary acts in the modern world. You reach into the refrigerator, pull out a carton of cold milk, and pour a generous splash into your coffee or over a bowl of cereal. It is a mindless, quiet ritual, a staple of the human experience that we take entirely for granted. But if you were standing in this exact same spot 10,000 years ago, that simple act would be a calculated risk, a gamble with your own survival that most of your ancestors would have lost. For the vast majority of our history, the milk of another animal was not a beverage. It was a biological weapon that the human body spent millions of years learning how to reject with violent efficiency. We often think of ourselves as the masters of nature, the clever species that conquered the farm and domesticated the wild, but for most of our existence, we were a species in a state of physiological war with our own food. The white liquid in your hand represents a miracle of adaptation, but for the people who built the first civilizations, it was a lethal puzzle they hadn't yet solved. We were never supposed to drink this. The common story we tell ourselves is that milk is a superfood, a natural gift that helped our ancestors grow strong and healthy. It's a comforting thought, but it's a complete myth. In reality, for an adult human in the ancient world, fresh milk was a digestive disaster. Evolution had a very specific plan for milk, and that plan ended the moment you stopped being a baby. In nature, milk is a high-octane biological fuel designed for one purpose: to turn a small, vulnerable infant into a larger, more independent juvenile as quickly as possible. To do that, the body produces a specialized enzyme called lactase. This enzyme's only job is to break down lactose, the complex sugar found in milk, into simpler sugars like glucose and galactose that your bloodstream can actually absorb. Once a mammal is weaned and starts eating solid food, the body makes a cold, efficient calculation. Producing lactase is energetically expensive, and since an adult animal in the wild will never see a drop of milk again, the body simply flips a genetic switch and stops producing the enzyme entirely. This is the biological default for every mammal on Earth, from mice to blue whales. For almost every human who lived before the last few thousand years, becoming an adult meant losing the ability to process milk. We weren't intolerant, we were simply finished with infancy. But what happens when a species decides to ignore the rules of nature and keep drinking anyway? To understand the danger, you have to look at what happens inside the gut of an ancient human who dared to drink a bowl of fresh cow's milk. Without the lactase enzyme, that lactose doesn't get absorbed in the small intestine. Instead, it travels further down into the colon, still fully intact. This is where the physics of the human body becomes a threat. Lactose is a large molecule, and when it sits in your large intestine, it creates an osmotic pressure that begins to pull water out of your surrounding tissues and into your gut. It is effectively an internal flood. At the same time, the billions of bacteria living in your biome realize there is a massive, untapped energy source sitting right in front of them. They begin to ferment the lactose, producing a violent eruption of gases, hydrogen, carbon dioxide, and methane. For a modern person, this results in bloating and discomfort. But for an ancient human, already potentially weakened by parasites, malnutrition, or a lack of clean water, the resulting osmotic diarrhea was a physical crisis. It wasn't just an inconvenience, it was a rapid, dehydrating drain on the body's most precious resources. Is it any wonder that for most of our history, we treated milk with a profound biological suspicion? This creates a massive paradox that has haunted archaeologists for decades. If milk was so dangerous to the adult human body, why do we see the evidence of dairying everywhere in the ancient world? In the early 2000s, researchers like Richard Evershed from the University of Bristol began looking at the chemical ghosts left behind on ancient pottery. They used a technique called gas chromatography mass spectrometry to analyze the microscopic pores of ceramic vessels from the Neolithic period. What they found was staggering. In sites across the Fertile Crescent and into Europe, dating back as far as 9,000 years, the pottery was saturated with milk fats. These ancient farmers were milking cows, goats, and sheep on a massive scale, thousands of years before the genetic mutation for milk tolerance became common in the human population. We have found ceramic sieves from Poland that look exactly like modern cheese strainers, and they are nearly 7,000 years old. These people were obsessed with dairy, even though their own DNA was telling them to stay away. They were surrounded by a food source they couldn't safely consume in its raw form. But if the very act of drinking milk was a gamble with death, why did these early pioneers refuse to let the dream of the dairy farm die? The answer lies in the fact that humans are the only species that uses technology to bypass our own biological limitations. Long before our genes changed, our culture found a loophole. Our ancestors discovered that while fresh milk was a poison, milk that had been manipulated was a lifeline. They learned that if you let milk sit in a warm pot, the natural bacteria in the environment would begin to eat the lactose for you. This process of fermentation turned the milk into yogurt or kefir, significantly lowering the lactose content and making it much easier on the adult stomach. Even more effectively, they learned to make cheese. When you curdle milk to make cheese, most of the problematic lactose remains in the liquid whey, which is drained away. The solid curds that are left behind have a fraction of the lactose found in fresh milk, and if you age that cheese for a few months, the remaining bacteria finish the job until the lactose is virtually gone. These ancient farmers weren't drinking cold glasses of milk, they were eating aged cheeses and fermented creams. They were using the microscopic world of bacteria as an external digestive system. It was a brilliant, manual override of evolution. But did this cultural shield make us complacent, or was there an even darker reason we kept these animals around? For a long time, scientists assumed that once we started farming, the mutation for lactase persistence, the ability to drink milk as an adult, simply spread because milk was such a great source of calories. It's a very clean, logical theory. The people who could drink milk got more food, they had more babies, and the gene won. But in 2022, a massive study published in the journal Nature completely dismantled this superfood theory. A team of researchers, including Professor Mark Thomas from University College London, analyzed DNA from thousands of ancient skeletons and compared it to the fatty residues found on over 13,000 pieces of pottery. What they discovered was a shock to the scientific community. They found that for more than 5,000 years, the use of dairy and the presence of the milk-drinking gene had almost no correlation. People were using dairy products in massive quantities for millennia, but the mutation for lactase persistence remained incredibly rare. It didn't slowly creep up as milk became available. Instead, the gene stayed at nearly 0% of the population for thousands of years, and then, in a very short window of time, it exploded. It wasn't a slow walk toward progress. It was a sudden, violent spike in the genetic record. But what could possibly be powerful enough to force the human genome to rewrite itself in the blink of an evolutionary eye? This brings us to the famine and pathogen theory, which is perhaps the most chilling explanation for why you can drink that milk today. The 2022 study suggested that the mutation didn't spread because milk was a helpful snack. It spread because, during times of catastrophe, milk was the only thing left. Imagine an ancient village during a massive crop failure or a prolonged famine. The grain is gone. The wild game has been hunted out. The only thing you have left are your cows, which can turn inedible grass into liquid calories. In a normal year, an ancient human who was lactose intolerant could eat a little bit of cheese or yogurt and be fine. Even if they drank some fresh milk and got a bit of an upset stomach, it wasn't a big deal. But in a year of starvation, your body is already at its breaking point. If you are starving and you drink fresh milk to stay alive, that upset stomach becomes a lethal liability. The osmotic diarrhea doesn't just cause discomfort, it flushes the last of your nutrients and water out of your body. In the middle of a famine, being lactose intolerant wasn't just an allergy, it was a death sentence. The same was true during outbreaks of disease. When a population is hit by a pathogen that causes intestinal distress, the people who can't process milk sugar are the first to succumb to dehydration. The mutation for lactase persistence didn't spread because it was a gift. It spread because everyone who didn't have it was wiped out during the worst moments of human history. Nature didn't choose the milk drinkers. It simply discarded everyone else. Is it possible that your ability to enjoy a milkshake is actually the surviving scar of 1,000 ancient famines? When we look at the genetics of this mutation, we see just how specific this battle was. In Europeans, the ability to drink milk is tied to a single typo, in our DNA, a mutation known as -13910*T. This isn't actually located inside the gene that makes lactase, which is called LCT. Instead, the mutation is found in a nearby stretch of DNA called MCM6. This region acts like a remote control for the lactase gene. In most mammals, the remote control sends a signal to turn off the lactase production after weaning. But in people with this specific mutation, the signal is broken. The body simply forgets to stop making the enzyme. It is a loss-of-function mutation that turned out to be a massive advantage in a world of recurring disasters. We didn't evolve a new, better way of digesting. We simply suffered a genetic glitch that kept us in a state of permanent biological infancy. We became Peter Pan mammals, unable to grow out of our need for milk because those who did grow up didn't survive the winter. But if this mutation was the only way to survive, why does the rest of the world look so different? This is where the story of milk becomes a global mystery of convergent evolution. While the European mutation is the most famous because it was studied first, it is far from the only one. In East Africa, among pastoralist groups like the Maasai, researchers discovered entirely different genetic mutations that achieve the exact same result. These people have been herding cattle for thousands of years, and their bodies reached the same biological solution as the Europeans, but they used a different typo in their DNA to get there. We see similar independent mutations in parts of the Middle East and the Arabian Peninsula. This tells us that the pressure to drink milk was so intense that humanity actually solved the problem multiple times, in multiple places, using different genetic pathways. It is one of the clearest examples of gene-culture coevolution in the history of our species. We didn't just wait for nature to change us. We created a culture of herding that forced nature's hand. We changed the environment around us so much that our bodies had no choice but to follow. But as we look across the globe, we find that some of the most successful dairy cultures in history never developed the mutation at all. How could a civilization build its entire identity around milk without ever gaining the genetic right to drink it? The people of Mongolia are the ultimate masters of this biological workaround. Dairy is the absolute cornerstone of the Mongolian diet. It is estimated that some nomadic herders get up to half of their total calories from the milk of cows, yaks, sheep, goats, camels, and horses. And yet, when geneticists tested these populations, they found that the vast majority of Mongolians are technically lactose intolerant. They don't have the persistence gene that Europeans or East Africans have. Their bodies are biologically ancient, still turning off the lactase enzyme after childhood. But they don't get sick, and they don't die of dehydration. Because they have perfected the art of microbial partnership. The Mongolians use a staggeringly complex array of bacterial cultures to transform their milk into a dizzying variety of products: dried curds, fermented mares milk known as arag, and heavy butters. They don't rely on their own human genes to digest the milk. They rely on the genes of the bacteria they have been cultivating for generations. Their lactase isn't in their DNA, it's in their buckets and their fermentation bags. They proved that you don't need to change your biology if you are clever enough to change your food. But if the Mongolians could thrive without the mutation, does that mean the famine filter in Europe was even more brutal than we imagined? As we piece together this history, we realize that the ancient world was a much more precarious place than we often assume. The milk-drinking gene is a marker of struggle. It is most common in places where the weather is unpredictable, where the winters are long, and where the threat of famine was a constant shadow over the population. In Northern Europe, where the gene reaches its highest frequency, the superfood wasn't a luxury, it was a desperate backup plan. When the wheat froze in the fields and the stored meat went rancid, the cow in the barn was the difference between a family surviving until spring or perishing in the cold. The lactase persistence gene is effectively an emergency survival kit that we eventually turned into a lifestyle. Today, roughly 1/3 of the global adult population can drink milk without issue, but that means 2/3 of the world is still operating on the original, ancestral human settings. To them, the way we drink milk today isn't normal, it's a biological anomaly. We are the weird ones. We are the species that refuse to grow up, the mammals that insisted on drinking the milk of another species even when our own bodies screamed at us to stop. But as we look at the modern world, dominated by dairy aisles and ice cream shops, we have to ask, was the cost of this evolution higher than we realized? The physical danger of milk in the ancient world also reminds us that domestication was never a one-way street. We think of ourselves as the ones who domesticated the cow, but the cow also domesticated us. By tying our survival to the health of our herds, we changed where we lived, how we worked, and how we interacted with the world. We moved into grasslands that couldn't support crops but could support cattle. We developed a concept of wealth based on living animals rather than stored grain, which changed the nature of war and social status. And most importantly, we entered into a lifelong pact with another species. We provided them with protection and breeding, and in return, they provided us with a renewable source of energy that could save us from the brink of extinction. But this pact came with a price. Living so closely with animals exposed us to a whole new world of pathogens. Diseases like tuberculosis and smallpox likely jumped from our livestock into our own populations. The milk we drank was often contaminated, and the famine filter that gave us the lactase gene was also a filter that selected for people with tougher immune systems. Every time you take a sip of milk, you are benefiting from a massive, multi-millennial experiment in human suffering and resilience. But how much of that ancient struggle is still hiding in your own biology? Think back to that carton of milk you hold in your hand every morning. You probably check the expiration date to make sure the milk hasn't gone bad. But for most of human history, the milk was never good to begin with. The very concept of fresh, sweet milk as a healthy beverage is a historical blink of an eye. It required the invention of refrigeration, the development of pasteurization, and a radical shift in our genetic makeup just to make it a reality. Before the 19th century, drinking a tall glass of raw milk was an invitation for a variety of bacterial infections and a guaranteed bout of digestive distress for most of the world's population. We have spent thousands of years cleaning the milk, fermenting the milk, and eventually evolving for the milk. We have rebuilt our society and our very DNA around a liquid that was originally intended to be a temporary bridge between birth and solid food. We are the only creature on this planet that has successfully hijacked the infancy of another species and turned it into a lifelong fuel source. But even now, with all our technology and our specialized genes, our relationship with milk remains a fragile one. The reality of our dairy history is that it wasn't a smooth climb toward better nutrition. It was a desperate scramble for survival. The reason most ancient humans couldn't drink milk is that their bodies were working exactly the way nature intended. They were adults, and adults don't need milk. It was only when the world became too cold, too hungry, and too dangerous that we were forced to break the rules. We turned a biological limitation into a cultural technology, and then we let that technology burn itself into our genetic code through centuries of famine and disease. We are the descendants of the people who were desperate enough to drink the poison and lucky enough to have a genetic glitch that turned it into a cure. Our ability to digest milk is not a sign of our perfection. It is a sign of how close our ancestors came to the edge of the abyss. Every glass of milk is a tribute to 1,000 generations of people who found a way to survive when everything else failed. But there is one more detail to consider before you finish that glass of milk. Scientists have noted that while the lactase persistence gene is a massive advantage in a world of starvation, it is completely unnecessary in a world of abundance. In the modern world, where calories are everywhere, that genetic typo doesn't actually help you survive any longer than someone who is lactose intolerant. We are carrying around an evolutionary emergency kit for a disaster that, for many of us, hasn't happened in centuries. We are living in a biological time capsule, shaped by the nightmares of our ancestors. And as you put that carton back in the fridge and go about your day, you might want to consider just how much of your normal life is built on the survivors of those nightmares. It's a quiet thought, one that usually disappears as soon as the coffee kicks in. But it's worth remembering that for most of the people who ever lived, the simple act you just performed would have been the beginning of the end. Does it ever make you wonder what other hidden survivors are lurking in your DNA, waiting for a crisis that hasn't arrived yet? We often think we are the masters of our own evolution, But the story of milk shows that we are often just the lucky leftovers of a much harsher world. If you enjoyed this dive into the secret wars of our ancestors, consider subscribing to help us dig deeper into the mysteries of how we became the strange, persistent species we are today. We are constantly uncovering new evidence of how our past is still dictating our present. What other ordinary parts of your life are actually ancient survival tactics? You finish your coffee, you rinse the glass, and you set it in the sink. The milk is gone, and the kitchen is quiet again. But as you walk away, take one last look at the expiration date on that carton. It's a simple set of numbers, meant to tell you when the liquid inside will finally return to its natural, fermented state, the state our ancestors relied on for thousands of years to keep the poison at bay. We like to think we've conquered that expiration date, that we've finally made milk safe for the adult human. But the truth is more haunting. The milk hasn't changed. The animals haven't changed. The only thing that changed was us. We are the ones who were broken by famine and rewritten by disease until we could finally swallow the one thing we were never meant to have. And that date on the carton? It's not just a warning for the milk. It's a reminder of a time when the only way to stay alive was to become a biological anomaly, a permanent infant in a world that had no mercy for the grown-ups. You can drink the milk now, but never forget, your ancestors had to die in the mud for the right to pour that glass.